We're going to continue talking about distribution. So when we're telling about the distribution of data, we always start with drawing a picture. That's the 3 rules of statistics being make a picture, make a picture, make a picture. Since we're using quantitative variables, we're going to start with a histogram or a stem and leaf plot. Then we go into discussing the shape of the distribution. So once we have our histogram or stem and leaf plot, we always report the shape of the distribution along with the center and spread. If the shape is skewed, we're going to report the median and IQR. If the shape is symmetric, we're going to give the median and standard deviation, but we may also give the median and IQR. Typically we would do this if we have outliers because the mean and standard deviation are subject to influence of an outlier where the median and IQR are not. After you've discussed the shape, center, and spread, you then want to look at unusual features. If there are multiple modes, we want to try and understand why. If we are able to identify a reason for the separate modes, it's sometimes a good idea to split the data into 2 groups, or at the very least, report the shape, center, and spread of each mode separately. If there are outliers, it's often a good idea to give the mean and standard deviation both with and without the outlier, because the difference can sometimes be quite revealing. The median and IQR are not affected by outliers, so therefore you wouldn't have to find those twice. Context. In statistics, the numbers and data are important, but it's the story that they tell that is what we are most interested in. This is in the form of context. You will hear me say all year long, it has to be in context. I cannot emphasize this enough. When you describe the distribution of data, it must be in context of the data you are given. This is done by stating what the data is representing and making sure that you are using the units with the numbers in the description. Let's go ahead and look at an example. The students in a biology class kept a record of the height in centimeters of plants for a class experiment. Then we want to describe the distribution. We're given the histogram here. So what we want to do is we want to look at the histogram and get an overall idea of the shape, what kind of center and spread we might be looking at, and if there are any unusual features. Right off the bat, this appears to be unimodal because there's only one mode, and it appears to be roughly symmetric. It's not perfect, but it doesn't have to be perfect, but it does appear to be roughly symmetric. I wouldn't really consider this to be an outlier, but there is a gap between 70 and 75, so that may be of interest. Because we're not actually given a list of the actual data, when we're describing the center and spread here, we're going to have to estimate. Now this isn't an outlier, but I would say that the higher value is going to cause the center to go up a little bit. So I might say that the center is probably going to be between 50 and 55. When we're talking about the spread, because we aren't given the data, we can't estimate the standard deviation or the IQR. So it's okay to give the range in these situations. So saying that the data ranges from 30 to 80 is perfectly appropriate. Now, I think that in this original example, we actually had the data, so I actually am going to give the actual mean and standard deviation here. But if you don't have the data, it is okay to estimate. So we would write this out as the distribution of plant height is unimodal with the mode between 45 and 49 centimeters. The data are roughly symmetric with no outliers. However, there is a small gap from 70 to 75 centimeters. The average plant height is 51 centimeters with a standard deviation of 10.6 centimeters. We gave the mean and standard deviation here because the data are unimodal and symmetric. We also explain what the shape is, and we talk about the small gap being an unusual feature. We also included the context here because I'm expressing that we're talking about plant height and that the plants were measured in centimeters. So when you're describing distribution, you always want to make sure that it's going to be in context. You give the shape, the center, and the spread. Let's go ahead and look at a second example. So here we're given the list of the weight of pennies in grams. We're also given the histogram, and we want to describe the distribution. Because we're actually given the data, we know that we'll be able to calculate the center and spread, whatever we happen to use. Looking at the histogram, we can very clearly see that this is bimodal. The first mode, which ranges from 2.4 to 2.6, is roughly symmetric. But the higher mode, which ranges from 3 to about 3.15, is very clearly skewed to the left. Because the second mode is skewed, we're going to end up using the median and IQR for that second mode. We could use the mean and standard deviation on the first one, but because this is from the same data set, we're going to want to be consistent. So since we have a mode that's skewed, we're actually going to go ahead and find the median and IQR for both the lower mode and the higher mode. So this written out would look like the distribution of weights of pennies is bimodal. About half the pennies are in the lighter cluster, which is roughly symmetric with a median weight of 2.495 grams. Half of the lighter pennies weigh between 2.465 and 2.525 grams. This will end up giving us our IQR. The rest of the pennies are in the heavier cluster, which is slightly skewed to the left, with a median weight of 3.095 grams, where half of the heavier pennies weigh between 3.07 grams and 3.13 grams. Again, that will give us the IQR. This means that each group has an interquartile range of 0.06 grams. After a little research, we found out that the different modes is because they stopped using copper and started using zinc in the early 80s. So what we thought was one population of pennies is actually two, those minted before the switch and those minted after the switch. Note that, again, we use the median and IQR to describe the lighter cluster, even though it is a symmetric distribution. That is because we were comparing it to the heavier cluster, in which we had to use the median and IQR since the distribution was skewed. That is the end of the lesson. I will see you all in class tomorrow. Have a good night.